Alright, for this set of videos we're going to talk about the propagation of plants, and we're going to start by talking about the sexual propagation of plants. With sexual propagation, we must first understand these two terms that we talked about in the past, pollination and fertilization. If you would recall, pollination is when the pollen on the anther is transferred to the stigma of the pistil of the flower, so from the male part to the female part of the flower. And then fertilization takes over when that pollen travels down the style and touches the ovules inside the ovary. So types of pollination. There's self-pollination and there's cross-pollination. Self-pollination is when the pollen from the same plant is transferred to the stigma of the same plant. Hence, it pollinates itself. So self-pollination, it pollinates itself. Cross-pollination is when the pollen from a plant is transferred to the stigma of a different plant. Hence, the pollen crosses from one plant over to another plant. Cross-pollination leads to a hybrid. If you notice in the image right here, this petunia, this flower right here, this petunia was crossed between a red and a white petunia, and this was so happened that this seedling was able to produce a red and white star flower. So a hybrid is nothing more than a cross between two plants. So you are a hybrid of your parents. So the resulting plant from the seed that was a result of a cross-pollination is a hybrid. So true to seed or true to type. True to seed plants, they look the same and have the same characteristics as their mother plant. So their parent plant that produced it is their mother plant. As you notice this tomato in the top right corner, the tomato on the right obviously looks probably like its mother plant's tomato, and therefore it is true to type or true to seed. This tomato on the left obviously has some genetic mutation where it formed many little tomatoes on top of the larger tomato, and it is not true to type. There is a mutation there. So what is sexual propagation? Sexual propagation is nothing more than starting plants from seeds. So some terms we'll discover is germination and viability. So seed germination. Seeds that come alive. That is essentially what germination means. They make it out of the seed. As you notice in the bottom left right here, the seed is actually germinating. As you can see, the radicle, that first root comes out, and then the cotyledons emerge, and then the leaves emerge, and then you have a new plant. So germination rate is the percent of seeds that sprout. An example would be if 75 seeds germinate out of 100, you would have a 75% germination rate. 75 over 100 equals 75%. So let's try a couple of these so that we understand germination rates. So what is germination rate of the following? If you have 30 out of 50 seeds, you would have a 60% germination. You just do 30 divided by 50, and that would equal 60%. If you have 22 seeds out of 25 seeds to germinate, that means 3 of them did not germinate, you would have an 88% germination. If you have 643 seeds out of 1,000 seeds germinate, that means that 643 of these seeds germinated and the rest of the 1,000 did not. Therefore, you would have a 64.3 germination. So 643 over 1,000, convert that to a percent, is 64.3% germination. So germination rates. How do you have some of these seeds that do not come up? Like what causes them not to come up or not to germinate? So they are affected by temperature and moisture. Different seeds require different moisture requirements. If there's not enough moisture, they're not going to germinate. If there's too much, they may not germinate. And also if it's not at the right temperature. There's different plants, especially like pansies. They're very finicky and they're very specific as to what temperature they need to germinate. If it's not kept at that temperature, they will not germinate. So the rate varies depending on type of plant and quality as well. This seed quality is referred to as the viability. So seed quality is the seed viability. If it's quality seed, then it has a good viability. So seed viability, the seed's capability of growing or developing. It is affected by temperature and moisture. So the seed viability is its capability of growing or developing. It's basically the quality of that seed. So some seeds need treatment. Two concepts that we'll a demonstration and work on in class is stratification and then scarification. Stratification is chilling seeds to simulate winter conditions before germinations. Basically, you're doing nothing more than taking these seeds and putting them in a baggie in the refrigerator. And it'd be in the refrigerator about 60 to 90 days, and it simulates that winter chill that it would get if it was in nature or in the wild. Some examples are baptisia and daylilies. So another type of seed treatment is scarification. Just like the name says, you're going to scar that seed. So you're breaking the seed coat. So basically what you do is, like as you see in the bottom right here, he is cutting the outer hard coat of the seed. You can also do this with acid like vinegar, sulfuric acid. You can do it with sandpaper, boiling water. There's many different ways to actually cut or break the outside of that seed. An example that you would do this on are red buds or maples. So planting seeds. How deep to plant seeds ultimately depends on the size of that seed. Larger seeds will be planted deeper, smaller seeds will be planted more shallow. So the general rule of thumb is you plant seeds no more than 1.5 times the diameter of the seed. So if you have a seed that is very large, you're going to plant it deep. And if you have a seed that is very small, there's many seeds out there that are almost microscopic, like orchid seeds. You're obviously going to plant those shallow. If you plant something like petunia seeds that are very tiny, or even these orchid seeds, if you plant them 1 inch or 2 inches deep, they're most likely not ever going to be able to make it to the surface. Okay, you got to think those seeds are trying to push to the surface and reach light as quick as possible. And if they're really small, they're not going to have the energy to get that far up. So water small seeds from the bottom by soaking to prevent burying them. So if you were to water on top of the seeds, it could push the seeds further down into the soil. So we recommend actually having a trough of water or a tray of water, and you put the pots with the seeds in them in the water, and the water will actually soak up through the bottom of that soil through capillary action. So seedlings, small plants, they're called juvenile. The first set of leaves are called cotyledons. As you notice in the top left right here, you have a monocot. Mono meaning one, you have one cotyledon. Di meaning two, in a dicot you have 2 cotyledons. So these cotyledons are not the first true leaves. They're just a seed leaf that helps the plant get started with photosynthesis. So true leaves are the second set of leaves to emerge. You can notice that true leaf right here. In the middle, you have this true leaf. This is a dicot plant, and it has 2 cotyledons. These were the first seed leaves to emerge, and then now this plant has produced a true leaf. It has emerged after the cotyledons. So the rest of the leaves of this plant are going to look more like this, and they will no longer look like this. So transplanting seedlings. When you transplant seedlings, when the first true leaves appear, you don't want to transplant seedlings when it still has cotyledons. You're going to wait for that first true leaf. Before planting in the outdoor environment, it is important to reduce humidity and water and make the environment more like the outside to harden off plants. So when you harden off a plant, you're making the conditions more like the outside or what environment it will be transferred into. So if you grow something in high humidity, like in a greenhouse, and then you instantly put it outside in the heat, it may not be used to it, and it may result in shock and even death of that plant. So you're going to want to reduce those conditions and slowly transition it to less humidity and less water to treat it like it's going to go outside. You should hold the seedlings gently by the leaves when transplanting. Don't ever crush the stems of the plant. So an advantage of sexual reproduction. Why do we sexually reproduce plants? It is a fast way to get many plants. You can notice in the top right here, there are hundreds of these plants right here, or even thousands. It's a fast way to get many plants. It's easy to do, and ultimately it is cheap. It is very economical. It's going to be much cheaper than most of your asexual propagation methods. So 3 things: it is cheap, easy, and efficient. The disadvantages, however, these are some of the reasons that we would choose asexual propagation methods over sexual propagation methods. Is when planting seeds, some plants, especially hybrids, do not reproduce true to their parents. So with asexual propagation, we're getting a clone. With sexual propagation, with seeds, we're not entirely sure exactly what that seedling or that new plant is going to look like. It may not look like its parent. So plants are difficult to propagate from seeds as well. Not all plants, but some plants do not come up through seeds as well as they would through asexual propagation methods. So finishing up, a few plants that you can actually sexually propagate easily at home. You can buy these seed packages at Lowe's or any of your department stores. Are marigolds, you see in the top left, impatiens right here in the top right, begonias bottom left, petunias in this bottom right. You also do salvia, Shasta daisy, pansies. There are a lot of seeds out there. There are a lot of plants out there you can propagate through seeds. So that's all I got for you guys today. I hope you enjoyed and hope you know a lot more about sexual propagation.